Previously, you graphed quadratic equations in standard form. That's y equals ax squared plus bx plus c. And just like lines, there are two other forms of quadratic functions or equations, and we can use them to graph a quadratic equation. So first, the standard form of a quadratic is y equals ax squared plus bx plus c. And the vertex form, which is new for you, is y equals a times the quantity x minus h squared plus k. And this is called vertex form because h and k here, when put together, actually give you your vertex, hk. And remember, your vertex always lies on your axis of symmetry. And so from this equation, you can also pick out your axis of symmetry if you needed to. And that would be x equals, because it's a vertical line, h. So if you look at this key concept, it goes over the characteristics of a quadratic equation in vertex form. And I've already mentioned the vertex is hk. Be sure to note that this is a minus sign in here. So understand what that means if a plus sign suddenly shows up, that your h or your x coordinate or your vertex had to be negative to get that, and we'll go over that again. Again, this is your x-axis, your axis of symmetry is where your vertex lies, and so you can say x equals the h coordinate. And again, as in standard form, this parabola will open up if your a value is greater than 0, and it will open down if a is negative. So let's actually graph a quadratic function that's in vertex form. Here I have the equation y equals negative 1/4 times the quantity x plus 2, that whole thing squared plus 5. Your first step is to identify the constants. So the constants in this equation can be identified. A is your negative 1/4. H is a negative 2 for the reason I stated on the previous slide. And k is a positive 5. So from this information we can move to step 2, which is to plot the vertex. The vertex, according to the equation, is again hk, so h is a negative 2 and k is 5. And on our coordinate plane, which I'm going to make a little bigger here, we can find negative 2 and 5. So that again is telling us where our axis of symmetry is, where our vertex lies, just so we can finish graphing this. So step 3 is to draw the axis of symmetry, and remember that is h, so it's a negative 2, and I'll draw it with a dotted line, doing the best I can. There's h is a negative 2. And I'll label it. Sometimes I'll ask you to do that, so we might as well get in the habit. Okay, and then step 4 is, now that we have sort of an idea of where our parabola is, we need to pick 2 more points that are to the left or the right of that axis of symmetry. And so I will pick a 0, which is handy. I'll find f of 0, which you plug into the equation, negative 1/4, 0 plus 2 squared plus 5. So you get 2 squared, which is 4, and 1/4 of that is 1, which is a negative 1 because of that sign. Negative 1 plus 5 is 4. So at 0, you have a point 4. And you can reflect that now because that axis of symmetry reflects any point to the left. Okay, and if you wanted another point, which is always a good idea, f of 2, when you figure that out, would become a 1, so you also have a point at 2, 1, which is 1, 2, 3, 4 on the other side of your axis of symmetry. 1, 2, 3, 4, and right here. And you can see your parabola opens down, which should make sense because your a value is negative. And there you've graphed it, and remember this is vertex form. Here's an interesting kind of real-world problem. This is the Tacoma Narrows Bridge in Washington. It has two towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by that function shown there, and X and Y are measured in feet. They want to know the distance D between the two towers. There's a really cool video on the Tacoma Narrows Bridge. Hopefully I'll show that in class, otherwise you should look it up because it actually collapsed. Well, the old one did. This is probably the newer one. So we need to find that distance D, but before I do, we're going to need to find the vertex because this will tell me something about its horizontal distance from this tower. So looking at the equation, you can see it's written in vertex form. And so remember your vertex is HK, and my H is 1,400 feet, and K is 27 feet. And so if you know that this X coordinate is your horizontal distance left and right. So this distance here is 1,400 feet, and so in order to get the total distance, you would simply multiply that by 2 to get that it's 2,800 feet long. All right, down below are some guided practice problems. So go ahead and try some of these yourself. You're graphing them in vertex form, and then pause the video and come back and check the answers. Okay, and here are the answers that you should have come up with. The vertexes are in red. Those get pulled right out from the equation. You draw your axis of symmetry after you plot your vertices, and then you pick another 1 or 2 points in order to graph those. You should always be checking that your parabolas are opening up or down based upon the equation. Remember, if A is positive, they open up, and if A is negative, your parabola should be opening down. That's just another way to check yourself. All right, let's move on to the intercept form of a graph, and we will look at that key concept here. Intercept form is of this form written right here, where you have the number A still outside, but notice what's inside. You have x minus a number p times the quantity x minus a number q. And this p and this q are your intercepts. And you'll notice on the graph here that they show you that there's p0, so that's one x-intercept, and q0, which is your other x-intercept. In order to find the axis of symmetry, well, since it is an axis of symmetry, it's cutting this parabola in half, so you add the coordinates of p and q together and divide by 2, and that will give you your axis of symmetry here. Again, the graph opens up if a is greater than 0, and it will open down if you have a negative. So let's practice using intercepts in order to graph. Here I have an example. It is quadratic. There are 2 x values, and you need to recognize that it's in intercept form first. And so looking at it, you should be able to pick out the p's and the q's. Now remember, it was inherently in the equation negative signs right here. So because in our problem this is a +3, that means our p had to be a -3. And so we will write for our x-intercepts that we have -3, 0 for one of them, and that we have +1, 0 for the other one. So you go over to your graph and plot -3, 0, and a +1 and 0, and those are your 2 intercepts. Your next job then is to find your axis of symmetry. So you take your -3 intercept plus 1 divided by 2. That would be -2 over 2, which is a -1, which makes sense when you draw it in that your axis of symmetry would be located in between. Now your job is to locate the vertex, which you should know by now has to lie on your axis of symmetry. So if my axis of symmetry is at -1, I'm going to use that as my x-coordinate to find out what my y value is when x is a -1. So you would put 2 times -1 plus 3, I'm just substituting it into the original equation, which ends up giving you times 2 times a -2, And so you end up getting a -8. Now that is a coordinate pair for your vertex that lies on your axis of symmetry. And so you have -1, and then you go down to -8, and your vertex is located down there. And remember to use a check for yourself that my parabola better be opening up, because that value of A is positive. And so from there, you can simply draw your parabola. Here's a word problem using the quadratic function in intercept form. It says the path of a place-kicked football can be modeled by the function you see there, where x is the horizontal distance in yards and y is the corresponding height in yards. The question is, how far is the football kicked? We are looking for this distance here. It's a horizontal distance. And so we need to use this equation and find our intercepts. Now if you notice here, they just have an x there, and that represents your initial horizontal distance there. And so I'm going to write it in just a different way and put in the 0 that is connected with that. It's really x minus 0 because your x-intercept is 0 at its starting position. And then you have x minus 46. So you could say that p is 0 and q is 46. So the question is, how far is the football kicked? Well, I cannot determine how far it is kicked right now, but I do know that if I found the coordinate of my vertex and I saw how far that was there, that I could multiply it by 2 in order to get to the total distance. So it's sort of like the Tacoma Narrows Bridge problem again. And so my first job is to find the axis of symmetry, which is found by adding together your x-intercepts and dividing by 2. So I'll have 0 plus 46 divided by 2, which is 23. So this distance here to the vertex is 23 yards. And so to get the entire distance, you simply double it, and you can see it's 46 yards. That's the answer to A. The next question is, what is the football's maximum height? Well, we are looking for the value again of the vertex, but this time we're looking for the y-coordinate of the vertex because I want to know how high it is vertically. And so what we're going to do is we're going to evaluate that our equation when x is 23. Let me not write a y, I'm going to write I'm going to write f of 23. So let's look for y when x is 23 yards. And so we plug in our values. That's a negative, times 23. Oops. And then we will write 23 minus 46. And when you do the math, you get that at 23 yards, your height is approximately 13.8 yards. So that is this height here, 13.8 yards. Okay, so now let's have you practice using the intercept form here. So read the directions. They want you to graph the function and then label the vertex, the axis of symmetry, and the x-intercepts. So pause the video, do that, and come back when you're ready. All right, here are the answers I got, color-coded for you. So walk through those and make sure you have each step. Remember, the steps are to find your axis of symmetry first, that is in blue. Then you take that and graph it. You graph your two intercepts, and your final job is to find that vertex. Where does it lie on that line or axis of symmetry? And so we plug in our x value for the axis of symmetry to force our equation to tell us what the y value was. Also make sure you're checking that your parabola opens up if your a value is positive, and it opens down if your a value is negative. Now, just as with lines, when you had them in standard form or slope-intercept form or point-slope form, you could change them into each other's form by multiplying or working them or rearranging them. Well, you can do the same thing with quadratic functions. You can change them from intercept form or vertex form into standard form. And the way you do it is with that good old-fashioned concept of FOIL. So if you look at the example they give you here, this is clearly a problem that was in intercept form, and they're reminding you how to do FOIL. Remember, FOIL stands for first, outer, inner, last. of these two binomials. So if I take the first terms and multiply them, you get x squared. If I take the outer terms, x times 7, I get 7x. The inner terms give me 4x, and the last terms give me 28. So it looks like sort of the skeleton of a quadratic function that was in intercept form, and then when you FOILed it, you ended up with a quadratic function in standard form. So let's look at this problem below. I have y equals -2 times the binomial x plus 5 times the binomial x minus 8. Your first job is to do FOIL on that, and then we'll multiply through by that -2. And so your y will be just that -2 hanging out front, and then I'm going to take my first terms, which are x times x, and get x squared. My outer terms give me -8x. My inner terms give me 5x, and my last terms give me -40. And then we will clean that up and get -2 times x squared minus 3x minus 40. And now you can go ahead and multiply through that -2. So we're going to get -2x squared plus 6x plus 80 as our final answer, and that is a quadratic function in standard form. All right, let's change from vertex form to standard form. This one is the same idea. You can see I have my vertex there of 1 and 9, but I need it to get into standard form. And so what we do is we expand that multiplication, the x minus 1 squared. So I will get x minus 1 times x minus 1, and then plus 9 on the outside. So I'm going to go ahead and FOIL. You have your first terms. X times x gives you x squared. Outer term, -1x. Inner terms, -1x. And last terms of plus 1 with plus 9 on the outside. Now, my next job is to distribute that 4 according to the order of operations. I have to do that next. So you're going to have 4x squared. I could have combined my like terms in here, which I'll do now. That's a -2x times 4 gives me a -8x, and then plus 4, and then plus 9 on the outside, which now you can simplify to 13. All right, so there is how you go from vertex form into standard form. And you might want to practice some of these problems. In your textbook on page 248, there are some guided practice problems, 9 through 16, that you would probably want to look at. This is actually a really important concept before we move on, so make sure you know how to do it.